Hey there, welcome back to another math lesson hosted by Book&Table. I am your tutor, Maurice Wright, and in this chapter we are going to review how to solve equations. We'll kick things off by taking a look at the different components of an equation. We'll then discuss how to remove those components, which are the constants and coefficients, so that we can solve for a variable, such as x. And then we'll wrap things up by discussing how to check your answer for these equations and how to solve equations that include the absolute value signs. Remember, if you have any follow-up questions, feel free to leave them in the comments section or contact a tutor near you through bookandtable.com or check out our app on the App Store. So let's begin by first discussing what an expression is. An expression is a combination of symbols and operators. Symbols are just numbers or variables, and operators are the things that you do with those symbols. Add them, subtract them, multiply them, or divide them. So this is an example of an expression, 6 plus 4. We are combining two numbers with this operator. This is another example of an expression. We are combining a variable with a number with the operator right here. And this is also an example of an expression. We have one variable, which we are subtracting from another, and this variable is being multiplied by this coefficient. So let's discuss variables for a moment. A variable is a letter or symbol that represents a value that is not explicitly known. So here we have the number 4. Its value is 4, or positive 4 to be specific. But here we have 2 being multiplied by some variable x. We don't know what the value of this variable is, so it is not explicitly known. We do not know it just by looking at it. The letter x is often used as a variable, but any letter or symbol can be used. Hence, this expression, 4/3 z minus w. Both z and w, or any letter for that matter, can represent a unique value in the expression. So this is x plus 7, for example. It could also be written as q plus 7, c plus 7, so on and so forth. Now we have a few different components to these expressions. First, we have a coefficient, the 2 here, the 4/3 here, and although we don't see it, the number being multiplied by x here is 1. A coefficient is a rational number, an integer or fraction, being multiplied by a variable. So here we have 2 times x, 1 times x, and 4/3 times z. A constant is a fixed number in the expression not being multiplied by a variable. So in this expression, positive 4 would be our constant. In this expression, positive 7 would be our constant. And in this expression, we have one variable being subtracted from another, so we do not have a constant here. Now, an equation is created when you place an equal sign between two expressions. When an equal sign is between two expressions, the result is an equation. The two expressions on opposite sides of an equal sign have the same value. So here, if we combine the number 6 with the number 7, it has a total value of 13. So the expression on the left has the same value as the expression on the right. That is what the equal sign means. The opposite sides have equal value. It doesn't just have to be fixed numbers. We can have an equation that has a variable and a constant on one side, and we're stating that their combined value is equal to the value on the right side. When you're asked to solve an equation, what you're being asked to do is to isolate that specific value on one side of the equal sign and to place all the other values on the other side. So in the previous example, we had x plus 7 is equal to negative 13. Well, if we isolate x on the left side of the equal sign, we see that it has a value of negative 20. This can also be done with variables. If you are given a minus b is equal to c, and you're being asked to solve for a, if you isolate a on one side of the equal sign, we see that it has a total value of c plus b. Now, before we get to how to solve these, I first want to discuss balancing equations. Since an equal sign represents an equal value on both sides, whenever a constant is added to or subtracted from one side, the same must be done to the other side. So if we have an equation a plus b is equal to c, and we want to isolate a, we need to negate this positive b. Well, positive b and negative b have a combined value of 0, which allows us to remove this altogether. A plus 0 would just be a. But if we do it on the left side, subtract b, we must also do the same thing on the right side, subtract b. So we see that a is equal to c minus b. If we do not keep the equation balanced, here's what happens. Let's say we have 4 plus 5, we know that that equals 9. Well, if we want to isolate 4, we would subtract 5. But if we only do that from the left side, we wind up with 4 is equal to 9, and that is not true. But if we subtract 5 from the right side as well, we do end up with a true statement, which is 4 is equal to 4. All right, so remember, when you are solving an equation, you have to keep the equation balanced. Whatever you do to one side, you must do to the opposite side as well. Now let's discuss constants. Removing a constant specifically. If a constant is added to the same side as the variable, then subtract the same value as the constant from both sides to keep the equation balanced. So in this first example, a plus b is equal to c. If we want to solve for a, since we're adding b, we subtract b from both sides to negate the b's, leaving us with just a on the left side, and that's equal to c minus b. Another example, x plus 7 is equal to negative 13. Since we're adding 7 to the left side, we want to subtract 7, giving us a total of 0, so we can remove it, allowing us to isolate x on the left side. Since we subtract 7 on the left side, we must also subtract 7 on the right side. Negative 13 minus 7 would then be equal to negative 20. If we are subtracting a constant from the same side as our variable, then what we do is add the same value as the constant to both sides to keep the equation balanced. So negative b and positive b cancel each other out, leaving us with a is equal to c plus b. In this example, x minus 11 is equal to 5. Negative 11 and positive 11 cancel each other out, so we add 11 to cancel this negative. Since we add 11 on the left side, we also add 11 on the right side, leaving us with x is equal to 5 plus 11, which would give us 16. Let's have you try a few practice questions on your own. Solve for x in the following equations. Question number 1, x minus 5 is equal to negative 12. Question number 2, x plus 7/3 is equal to 5. And question number 3, z plus y minus x is equal to 49. Pause the video, solve these questions, and then press play when you are ready. Since we are subtracting 5 on the same side as the variable we want to solve for, we want to negate this negative 5 by adding 5, giving us a total of 0, and allowing us to isolate x on the left side. Since we add 5 to the left, we must also keep the equation balanced by adding 5 to the right side. So negative 12 plus 5 would give us negative 7. So x is equal to negative 7. Let's take a look at question number 2. Now in this one, we have a unique situation. The constant on the same side as our variable is a fraction. So if we want to subtract this fraction from the left side, we need the number on the right side to have a common denominator. So step 1, we want to convert the constant on the right side, which is 5, to the same denominator as the constant that will be removed, which is 7/3. You may remember, to convert a number to a different denominator, you multiply it by that number over itself. 3 divided by 3 is equal to 1. 5 times 1 would still equal 5. So we are not changing the actual value of 5. We are simply changing how we represent that value. So instead of the number 5, we represent it with 5 times 3 over 3, which would give us 15 over 3. So now our equation is set up nicely so that we can subtract the 7/3 in step 2. Subtract 7/3 from both sides of the equation. Positive 7/3 and negative 7/3 cancel each other out, leaving us with just x on the left side. 15/3 minus 7/3 would be 15 minus 7, which gives us 8/3. So the answer to question number 2 is x is equal to 8 over 3. And the last question, question number 3. Step 1, isolate the variable x by subtracting z and y from both sides. Since we are adding z and adding y on the same side as the variable we'd like to solve for, we want to do the opposite operation, which is subtraction. Z minus z would be 0, y minus y would be 0, leaving us with just negative x on the left side. Keep the equation balanced by subtracting z and y from the right side as well. So that leaves us with negative x is equal to 49 minus z minus y. And now step 2, remove the negative sign by multiplying both sides by negative 1. When you do that, negative 1 times negative x is going to give us positive x. Place this expression, since it has multiple terms, inside parentheses so that it's easier to remember that you have to distribute this negative 1 to each term inside of the parentheses. The negative 1 has to be applied to the entire expression. So negative 1 times 49 will give us negative 49. Negative 1 times negative z will give us positive z. And negative 1 times negative y will give us positive y. So our final answer is x is equal to negative 49 plus z plus y. Now you'll notice for these 3 practice questions, we did not discuss how to check these answers. So for the moment, just trust me that these answers are correct. But later on in the video, we'll dive a bit further into that. But first, let's discuss coefficients. A coefficient is a number or fraction multiplying the variable. So in this example, we have negative 4x. Our variable is x, and we're multiplying it by the number negative 4. So this would be our coefficient. Our coefficient can also be a fraction. 5c divided by 2 is the same as 5/2 times c. So our coefficient is the numerator and denominator, 5 over 2. And a third example would be like this one, k divided by 19. Our coefficient is 1 over 19. The 1 times k would be k. So we do not display the 1 just because it looks cleaner this way. But if you do not see a number in the numerator and the variable is being divided by a number or a variable for that matter in some examples, then the coefficient is going to be 1 over whatever term is in the bottom. Now, before we discuss how to remove coefficients, let's first discuss this idea of a reciprocal. If the numerator and the denominator are switched, then the resulting fraction is called the reciprocal. So if we have a fraction a over b, the reciprocal is the result when you switch the place of a and b. So a would come down here and b would go up here. So that is why these two fractions are reciprocals of one another. If you switch these two, you wind up with this term. If you switch these two, you wind up with this term. Now, the product of two reciprocal fractions is equal to 1. So in this example, a times b would give us ab. B times a would give us ba. b times a is the same as a times b, and we see that our numerator is being divided by the same exact term. Anything divided by itself would be equal to 1. Right, now why is this important? When you want to remove a coefficient that is a fraction, you do so by multiplying both sides of the equation by the reciprocal of this coefficient. So step 1, remove the coefficient by multiplying both sides by the coefficient by the reciprocal of the coefficient. Our coefficient is AB. Our coefficient is A divided by B. So the reciprocal is B divided by A. Since we're multiplying the left side by B over A, we want to multiply the right side by B over A. And again, what's happening here is B divided by B is equal to 1. A divided by A is equal to 1. 1 times X would just give us X. So the final result would be X is equal to 10 times B over A. If the coefficient includes a negative, whether the negative is placed out here or it's in front of A specifically or B specifically, when you multiply both sides by the reciprocal, you want to multiply with the negative included. All right, a negative times a negative will give us a positive, so the result will be positive X. All right, well, let's go back really quickly. 10 times negative B over A would be X is equal to 10 times negative B over A. Okay, so that is why reciprocals are important. Let's have you try a few practice questions. Solve for X. Question number 1, 5X is equal to 35. Question number 2, 7X over 9 is equal to 14. And question number 3, negative 4XY is equal to 20. Pause the video for a moment, solve these questions, and then press play when you are ready. (5x) is equal to 35. So if we like to solve for x, step 1, remove the coefficient, which is 5, by multiplying both sides by the reciprocal. Remember, 5 is the same as 5 divided by 1, which would be equal to 5. So the reciprocal would be 1 over 5. Now I wrote it like this just to show you that multiplying both sides by the reciprocal, and in this case dividing by 5, would have been the same. Right, you could divide both sides by 5, but I wanted to show you the reciprocal because when the coefficient is a fraction, this is more convenient. So anyway, we multiply the left side by 1/5. 1/5 times 5 is 1. 1 times x is x. And on the right side, 35 times 1 is 35. 35 divided by 5 is 7. So the answer to question number 1, x is equal to 7. Let's have a look at question number 2. 7x over 9 is equal to 14. So to negate this coefficient, 7 divided by 9, you want to multiply that side by 9 divided by 7. Switch the numerator and the denominator. 7 goes down, 9 goes up. Since you multiply the left side by 9 over 7, you multiply the right side by 9 over 7 as well, leaving us with x is equal to 14 times 9, which is 126, divided by 7, which would be equal to 18. So the answer to question number 2 is x is equal to 18. And then lastly, question number 3, remove the coefficient, negative 4y. We're multiplying all of these, so you can switch the placement of these terms. Like, for example, negative 4 times 2 is the same as 2 times negative 4. So this y, although it's on the other side of the x right here, can be considered to be a part of the 4. Negative 4 times y times x is the same. So we want to cancel the negative 4 since that's not the x, and we want to cancel the y because that's not the x. All right? So we divide both sides by negative 4 and y. Or multiply it by the reciprocal, which is 1 over negative 4y. Anyway, so that leaves us with x on the left side. And now on the right side, 20 times 1 would leave us with 20 in the numerator, divided by 4y with a negative. 20 divided by 4 would leave us with 5. So the answer to question number 3 is x is equal to negative 5 over y. Now let's discuss solving for x when we have both a constant and a coefficient present in the equation on the same side as the variable that we'd like to solve for. To solve for a variable x in an equation, first remove the constant and then remove the coefficient. So if we have negative 4x plus 7 is equal to 23, here is what it would look like. Step 1, remove the constant, positive 7, by subtracting 7 from both sides. Positive 7 and negative 7 cancel each other out, leaving us with just negative 4x on the left side. 23 minus 7 would leave us with 16. And now step 2, remove the coefficient, negative 4, by dividing both sides by negative 4. Negative 4 divided by negative 4 leaves us with 1 times x, which is x. 16 divided by negative 4 would leave us with negative 4. So the answer would be x is equal to negative 4. Now if we'd like to check this answer, we do so by plugging it back into the original equation. Negative 4x plus 7 is equal to 23. When we do that, we wind up with negative 4 times negative 4. Since this has the same value as x, we replace it. Negative 4 times negative 4 would be positive 16. Plus 7 would give us 23. So this confirms the value on the left side is the same as the value on the right side, which means our answer, x is equal to negative 4, is in fact correct. Okay, so that is how you check the answers when you solve an equation. Plug each number or expression back into the original equation to confirm that the left side of the equation equals the right side. Okay, so let's try a few more practice questions, and now we'll also have you check the answer. Question number 1, negative 8x plus 5 is equal to 21. Question number 2, 3x minus 1/2 is equal to 8. And question number 3, x divided by 4 plus 3 is equal to 11. Pause the video, solve these questions, and then press play when you are ready. Step 1, remove the constant, positive 5, by subtracting 5 from both sides. Positive 5 and negative 5 negate each other, leaving us with negative 8x on the left side. 21 minus 5 would leave us with 16 on the right side. Step 2, remove this coefficient, negative 8x, by dividing both sides by negative 8. Negative 8 divided by negative 8 cancels out the coefficient, leaving us with x on the left side. Since we divide the left side by negative 8, we divide the right side by negative 8. 16 divided by negative 8 is equal to negative 2. So the answer to question number 1 is x is equal to negative 2. And then to check this answer, step 3, we do so by plugging it into the original equation. Negative 8x plus 5 is equal to 21. So if we plug in negative 2 in the place where we see x, we get negative 8 times negative 2, which is 16, plus 5 would be 21. So this confirms that the value on the left side in this equation equals the value on the right side. Let's take a look at question number 2. 3x minus 1/2 is equal to 8. Since we want to remove a constant that is a fraction, we want to make sure the constant on the right side has a common denominator, which in this case would be 2. So step 1, convert the constant on the right to a denominator of 2. We do so by multiplying it by 2 over 2. 8 times 2 would give us 16 over 2. So step 2, remove the constant negative 1/2 by adding 1/2 to both sides. That leaves us with 3x on the left side. 16 over 2 plus 1 over 2 would give us 17 over 2. 16 plus 1, denominator stays the same. And now step 3, to remove the coefficient 3 from the x, we divide the left side by 3, and that is the same as multiplying both sides by 1 over 3. So that leaves us with x on the left side, and on the right side, 17 times 1 is 17. 2 times 3 would give us 6. So our final answer is x is equal to 17 over 6. And then finally, step 4, we check the answer by plugging it into the original equation. 3x minus 1/2 is equal to 16 over 2. So we plug in 17 over 6 here in place of x. 3 times 17 is 51 divided by 6. You must also convert this fraction to a common denominator now so that we can combine these two terms. Since the denominator we want is 6, we get to 6 by multiplying 2 times 3. So since we multiply the denominator by 3, we multiply the numerator by 3. 51 minus 3 gives us 48 over 6. And 48 divided by 6 is equal to 8. So 17 over 6 was in fact the correct answer, because we see when we plug 17 over 6 in for x, the value on the left is the same as the value on the right. Okay? And then for question number 3, x divided by 4 plus 3 is equal to 11. Step 1, remove the constant positive 3 by subtracting 3 from both sides. That leaves you with x divided by 4 on the left side and 11 minus 3, which is equal to 8 on the right side. And now step 2, remove the coefficient 1 over 4 by multiplying both sides by 4. All right, if you switch these to get the reciprocal, it would be 4 over 1, which is the same as 4. 4 divided by 4 is 1. 1 times x is x on the left side. 8 times 4 is equal to 32. So we see the answer to question number 3 is x is equal to 32. And then you check this answer by plugging it into the original equation. X divided by 4 plus 3 is equal to 11. And when you do so, you get 32 divided by 4, which is 8, plus 3. 8 plus 3 is 11. So we see the value on the left side is the same as the value on the right side, thus confirming that x is equal to 32 was indeed correct. Okay? And then the last topic in this chapter, absolute values. We'll first take a look at the geometric definition of the absolute value, which is the distance from 0 on the number line that the term, number, or variable is, that is inside the absolute value sign. So the absolute value of a number is the total distance away from the 0 that the number is, and is represented by two straight lines on both sides of the number. So this right here, the absolute value of x is equal to the absolute value of negative x, because they both have a total distance from 0 on the number line of x. You cannot have a negative distance between 2 points, right? So from 0 to negative x, you have to go a total of x units along the number line to the left of 0. That's all the negative represents, is it's to the left of 0. And you have to go a total of x units from 0 to positive x as well. So the absolute value, again, is just the total distance from 0 to said term on the number line. That is why the absolute value is always positive, because it's distance. So that's the geometric definition. The mathematical definition is as follows. The absolute value of a positive number x is equal to x. the absolute value of a negative number, negative x, is equal to negative 1 times negative x. So if you have the absolute value of negative x, that's equal to negative 1 times negative x, which would then give the positive representation of this term. If we replace x with an actual number 7, the absolute value of negative 7 is equal to negative 1 times negative 7, which would be equal to 7. All right, so remember, the absolute value is always going to be positive because it represents the distance away from 0 on the number line. Okay, this is just a reminder of how to turn a negative term into the value that it represents. And that value is always going to be positive. Okay? Here's another way to represent that. In the absolute value of x is equal to negative 1 times negative x if x is less than 0. So if this were negative, as we saw a moment ago. Okay? So let me walk you through an example of an equation that includes an absolute value term. Solve for x and check the answer or answers. The absolute value of 3x plus 7 is equal to 13. So we're solving for x. Now remember, the term inside the absolute value can be negative or positive, but once you place it inside the absolute value signs, it is always going to have a positive value. But what if the term on the inside, before you place the absolute values around it, are negative? That means without the absolute value sign, this could possibly equal negative 13. So when you solve an equation that includes an absolute value term, you have to solve this expression for the negative value, negative 13 in this case, and the positive value, 13. So step 1, remove the absolute value signs from the expression. So when we do that, we're left with just what's between them, which is 3x plus 7. And step 2, set the expression equal to the negative value of the expression. So take the positive value that they gave you and multiply it by negative 1. And this is what we wind up with. 3x plus 7 is equal to negative 13. And now step 3, we want to solve for x. So we first start off by removing the constant positive 7 by subtracting 7 from both sides, leaving you with 3x on the left side and negative 13 minus 7, which is negative 20 on the right side. And then to remove this coefficient, positive 3, we need to divide both sides by positive 3, leaving us with x is equal to negative 20 over 3. All right, so this is one possible value. If the expression is equal to negative 13, we must solve this expression again for the positive value, which in this case would be positive 13. So step 4, set the expression equal to the positive value of the expression. And then step 5, solve for x once again. So we remove the constant positive 7 by subtracting 7 from both sides, leaving us with 3x on the left side and 13 minus 7, which is positive 6 on the right side. We then negate this coefficient, positive 3, by dividing both sides by positive 3, leaving us with x is equal to 6 over 3, which is equal to 2. So one of our answers was negative 20 over 3. The other was x is equal to 2. So the final step is to check the answers by plugging them into the original equation. The absolute value of 3x plus 7 is equal to 13. And we plug both those values in place of x. When we do that with negative 20 over 3, 3 times negative 20 over 3, our 3's cancel out, leaving us with negative 20 plus 7. Negative 20 plus 7 is equal to negative 13, and the absolute value of negative 13 is positive 13. So when we plug in negative 20 divided by 3 in place for x, we confirm that the left side has the same value as the number on the right side, thus confirming that our answer was correct. Now x can have more than one value, so we still need to check the second answer that we got. So when we plug 2 in for x, we get 3 times 2, which is 6, 6 plus 7 is equal to 13. The absolute value of 13 is equal to 13, confirming that the value on the left equals the value on the right, and also confirming that our second answer, x is equal to 2, was indeed correct. So that is how you would solve an equation that includes an absolute value sign. Let's wrap things up by having you practice a few questions. Solve for x and check the answers. Question number 1, the absolute value of negative 2x minus 5 is equal to 3. Question number 2, the absolute value of negative 7 minus x is equal to 25. And question number 3, the absolute value of negative 4x plus 3 is equal to 15. Pause the video for a moment, solve these questions, and then press play when you are ready. Step 1, remove the absolute value signs from the expression, leaving you with just negative 2x minus 5 on the left side. And then step 2, set the expression equal to the negative value of the expression. The positive value is 3. The negative value would then be negative 3. And then step 3 is to solve for x. So since we're subtracting 5 on the same side as our x, we want to add 5 to negate it. Keep the equation balanced, so you add 5 to the right side as well, leaving you with negative 2x on the left side and negative 3 plus 5, which is positive 2 on the right side. And then to remove the coefficient negative 2, you divide both sides by negative 2, leaving us with x is equal to 2 divided by negative 2, which is x is equal to negative 1. So this is the first answer that we get for question number 1. Let's go ahead and find the second answer. So step 4, set the expression negative 2x minus 5 equal to the positive value of the expression. So now we keep our positive 3. And step 5 is to solve for x again. So we remove the constant negative 5 by adding 5 to both sides, leaving us with negative 2x on the left side and positive 8 on the right side. We can then negate this coefficient, negative 2, by dividing both sides by negative 2, leaving us with x is equal to 8 divided by negative 2, which is the same as x is equal to negative 4. Alright, so now we found our two potential answers. The last step is going to be to check the answers by plugging them into the original equation, which is the absolute value of negative 2x minus 5 is equal to 3. When we plug negative 1 in for x, we get negative 2 times negative 1, which is positive 2, minus 5. 2 minus 5 is negative 3. And the absolute value of negative 3 is positive 3. So this confirms that the value on the left equals the value on the right, and thus x is equal to negative 1. Let's check our second answer, negative 4. Negative 2 times negative 4 is positive 8. 8 minus 5 is equal to 3. And the absolute value of 3 is 3. So we confirm that x is indeed equal to negative 4. Okay, so the answers for question 1, x is equal to negative 1 and x is equal to negative 4. Question number 2, the absolute value of negative 7 minus x is equal to 25. Step 1, remove the absolute value signs from the expression, leaving you with negative 7 minus x on the left side. Step 2, once again, set the expression equal to the negative value of the expression. The positive value, right, this expression is equal to positive 25, so the negative value would be negative 25. Step 3, solve for x. First, remove the constant. So negative 7 is negated by positive 7. What you do to the left, you do to the right. Negative 25 plus 7 is negative 18. To remove this negative sign in front of the x, divide both sides by negative 1, or multiply both sides by negative 1. the result will still be x is equal to 18. So this is our first answer, x is equal to 18. Let's go ahead and solve for our second answer. Step 4, set the expression equal to the positive value of the expression. So that would be -7 minus x is equal to 25. And then step 5 is to solve for x. So we first want to remove our constant -7 by adding 7 to both sides, leaving us with -x on the left side and 25 plus 7, which is 32 on the right side. Divide both sides by -1, and you will get x is equal to -32. All right, so now the last step, step 6, check the answers by plugging them into the original equation, which is the absolute value of -7 minus x is equal to 25. -7 minus 18 will give us -25. The absolute value of -25 is +25. So we confirm that 25 is equal to 25, the value on the right side, thus also confirming that x is equal to 18. So this answer is correct. And then -32 was our second answer for x. -7 minus -32 is the same as -7 plus 32, plus, we turn that into. So -7 plus 32 is equal to +25. And the absolute value of 25 is 25. So we see that our second answer, x is equal to -32, is indeed correct. And then lastly, question number 3. The absolute value of -4x plus 3 is equal to 15. Step 1, remove the absolute value signs from the expression. So we wind up with just what's between them, -4x plus 3. Step 2, set the expression equal to the negative value of the expression. So instead of +15, it's -15. And then step 3, we want to solve for x. So to remove the constant on this side, +3, we subtract 3 from both sides, leaving us with -4x on the left side, and -15 minus 3, which is -18 on the right side. And then to remove the coefficient -4 from the x, we divide both sides by -4. So we wind up with x is equal to -18 divided by -4, which is the same as x is equal to 4.5. So this is our first answer. Let's solve x for our second value. So step 4, set the expression, -4x plus 3, equal to the positive value of the expression, which is the same number we're given, +15. And then step 5, solve for x. Remove the constant, +3, by subtracting 3 from both sides, leaving you with -4x on the left side, and 15 minus 3, which is 12 on the right side. And then lastly, you negate the coefficient, -4, by dividing both sides by -4. So you wind up with x is equal to 12 divided by -4, which is equivalent to x is equal to -3. And we can check both of these answers by plugging them into the original equation. -4x plus 3 is equal to 15. So we plug in 4.5 in for x, giving us -4 times 4.5, which is -18. -18 plus 3 is -15. And the absolute value of -15 is +15. So we are able to confirm that 15 equals 15. So x is equal to 4.5. And then we check our second answer. X is equal to -3. -4 times -3 is +12. 12 plus 3 is 15. The absolute value of 15 is equal to 15. And again, we can confirm that the answer we got was correct. And so x is also equal to -3. And that wraps up this chapter on solving equations. If you have any follow-up questions, feel free to leave them in the comments section. Or if you would like to contact a tutor in your neighborhood, visit bookandtable.com or download our app on the App Store. Peace.